Welcome, everybody. Sorry for the delay here. We have the wonderful committee who is leading Kubernetes version 1.34. Our maintainers, Graziano Castro and Rayan Das. They will further introduce themselves, but we are super excited to have you here on both LinkedIn Live and YouTube Live. This is a CNCF hosted live stream. So as with anything, we ask you to be respectful and kind to each other in the chat. We will be monitoring the chat for questions, so please feel free to ask your questions there. But without further ado, since we are 12 minutes over time here, I would like to hand it off to Graziano and Rayan. Graziano, why don't you start by introducing yourself?
Hello, everyone, and welcome to this CNCF Cloud Native Live event. We are going to talk about Kubernetes v1.35, which is the latest release we delivered in December. And it will be actually an overview of the whole release cycle, and we will have a quick overview of the most important changes we delivered within this cycle. There were supposed to be 3 of us for this event, but unfortunately Drew, which is actually the release lead for this cycle, couldn't make it. Quick presentation of ourselves. I'm Graziano Castro, I'm based in Italy, and I work as a DevRel engineer at Akemas, which is, in a nutshell, an AI-powered platform designed to optimize application performance, reliability, and cloud cost. During the latest release cycle, I stepped into the role of comms lead, and basically I worked side by side with my fantastic team to coordinate all the communication behind our release. And here with me, Ryan, would you like to present yourself?
Yeah, sure. Thanks, guys. Hey, folks, my name is Ryan Das. I'm based out of India. I work as a senior platform engineer at DigitalOcean. I was leading the enhancements team for 1.35, and I have been involved with release team since last 2 years now. So yeah, that's all about me.
Thank you so much, Ryan. So before we dive into the updates, I'd like to take a moment to thank everyone who made this release possible. The engine behind Kubernetes release is made first and foremost of people who put an incredible amount of effort to ensure that everything is going successful. And for those who might not know, we are organized into sub-teams, each with specific roles. So from managing documentation and coordinating 6 on planned feature to monitoring the overall health of the project and working on the communication side of the release. Every single person is essential, and without them, we would be here today talking about Kubernetes v1.35. So while I can't name every single contributor individually, I want to say a huge thank you to everyone, and especially to Drew, which is our release lead for the cycle, and Kat, which is the sub-project lead, that without their constant guidance and dedication, this journey would have been far more difficult, trust me. As you may know, every Kubernetes release has its own theme and logo. For this cycle, the version 1.35, our theme is Kubernetes, the World of Free. It's inspired by the legendary Yggdrasil, and it basically celebrates the spirit of our community, the community behind the Kubernetes project. Just like a grid tree, this project Kubernetes grows ring by ring, year by year, nurtured by the care of its contributor and its community. The logo itself tells the same story. At its center is the Kubernetes wheel wrapped by the heart, and it's grounded by its resilient maintainers, contributors, and users who make it a successful product. You will also notice at the bottom of the logo the 3 squirrels. In particular, you can see the wizard holding the LGTM scroll, representing our reviewers, the warriors with an axe and a shield representing the risk crews who actually cut new branches, and the rogue with a lantern for representing the triagers who bring light to the dark issue queues. And together, they basically represent all of us, all the contributors, and all the community behind the Kubernetes project. Let me talk about some numbers because before starting to talk about specific features. As you know, every Kubernetes release is built on KEPs, or Kubernetes enhancement proposals. For those who are new to the ecosystem, a KEP is essentially the blueprint for a new feature or a change into the project. It's basically the process where an idea is proposed, debated, and finally designed before actually a single line of code is written or merged into the project itself. It's a live document, it's a markdown document into a specific repository where all the information about the proposal are described, like goals and non-goals, how the feature must be tested to reach the production readiness, and the cool thing is that SIGs keep this document updated during the cycles so that it gives you a clear view about how the feature is progressing from the alpha stage to the general availability. For this specific cycle, we managed a total of 60 Kubernetes enhancement proposals. 17 of them are landing in alpha stage, 19 are progressing to beta, and 22 are reaching the general availability, the stable status. We also have free deprecation, but we will talk about that in more details later. Today, of course, we only have time to dive into a few of these. So if you'd like to see the full list, I highly recommend to see our tracking board on GitHub, which is linked on this slide. Now it's finally time to talk about the features themselves. Before I hand it over to Ryan, who will walk us through the first half of the selected highlights, I want to say that we will only be giving you an high-level overview today. Many of these KEPs have a dedicated deep dive post on the official Kubernetes blog. And if you are interested in the technical implementation detail or specific use case, I highly recommend you to check those blog posts or keep an eye on the specific Kubernetes enhancement proposal. So without waiting more, Ryan, the microphone is yours.
Yeah, thanks, guys. So before I move forward, the term SIG is basically called special interest group, if you don't know. So there are different SIGs in Kubernetes project that manage specific areas or components of the project. Like SIG auth focuses on improvements to Kubernetes authorization, authentication, and cluster security policy. So they had a couple of enhancements that went into Kubernetes 1.35. Next slide, please. Yeah, so this is the first one, constrained impersonation. So the work for this enhancement was done under the KEP 5.2. And as Graz already mentioned what a KEP is, so it's a Kubernetes enhancements proposal. You can find everything around KEP under the Kubernetes /enhancements repo, and read more about all the KEPs that went in to the current release. So now coming back to the KEP constrained impersonation. So it's in alpha, which got introduced in this release. So traditionally, Kubernetes impersonation lets a user act as another identity. So while useful, it also meant that by impersonating a more privileged user, you could end up performing actions you are not authorized to do yourself, so which is a potential security risk. So this KEP adds a security guardrail. It ensures that when you impersonate another user, you cannot perform any action that you yourself wouldn't be allowed to perform directly. So to use this feature, users can use the new authorization rules and verb prefixes like impersonate on and then mode and verb, which let admins tightly control what actions and resources are allowed during the impersonation. Next one. Yeah, so next one is pod certificates. Excuse me. Yeah, so this cap got added in, I mean, reached to beta in this current release after being introduced as alpha in previous one, the cap 4317. So previously, if you wanted X509 certificates inside pods for things like workload identity or MTLS, you had to rely on external tools like Cert Manager, Spiffy, Spire to handle issuance and rotation. So pod certificates brings this capability natively into Kubernetes. With this feature, the kubelet itself can request, rotate, and mount short-lived certificates directly into pods, making secure workload identity and MTLS much easier to adopt without extra components. So to use this feature, users can add a pod certificate projected volume to the pod spec and define a pod certificate request where you specify the certificate attributes you need. This results to simpler certificate management, tighter integration with Kubernetes, and a strong foundation for secure identity-based communication between workloads. Yeah, next one. So next we are next is SIG scheduling. So this SIG is responsible for components that make pod placement decisions within a cluster. So yeah, the first KEP is gang scheduling support in Kubernetes, KEP 4671. It got introduced as an alpha feature in this release 135. So traditionally, the Kubernetes scheduler handles pods individually. For distributed or batch workloads, this can cause issues where only part of a job gets scheduled, leading to partial execution or resource deadlocks. So gang scheduling changes this by introducing all or nothing model. So using the new workload API that got introduced, you can define a group of pods that must be scheduled together or not at all. So you can also, I'm sorry. Yeah, so you can also specify a minimum quota. So scheduling only happens when the cluster can support enough pods for the workload to make progress. Also, this feature can be used by creating a workload object that defines a pod group with a gang policy and then reference it from your pods using spec.workload ref. This is especially useful for distributed training, batch processing, and tightly coupled workloads. And it brings a long requested scheduling primitive directly into Kubernetes. So this KEP also has a feature blog if you want to check more details about it. Yeah, next one. So the next is extended toleration operators for threshold-based placement, KEP 4571, that got introduced in 1.35 as an alpha feature. So previously, taints and tolerance in Kubernetes relied on exact value matching, which made it hard to express placement rules. based on numeric thresholds. For example, node health or other SLA-related metrics. So this feature introduces comparison operators like greater than or less than, allowing pods to tolerate taints based on numeric ranges rather than exact values. Users can use this by specifying a value. I mean, you can basically specify a value and a comparison operator like GT or LT, which is greater than and or less than, directly in the pod's toleration field. So this enables much more flexible and expressive scheduling policies, especially for clusters that want to place workloads based on capacity, health, or performance threshold. Yeah. So next one is opportunistic batching, CAP 5598. So until previous Kubernetes version, the scheduler evaluated every pod individually, even when multiple pods belong to the same job and shared identical scheduling constraints. So at scale, this created unnecessary scheduling overhead. With opportunistic batching introduced as an alpha feature in Kubernetes 1.35, the scheduler can now optimize this behavior. So it identifies identical pods using a scheduling signature and schedules the pod normally, and then reuse the filtering and scoring results for the remaining pods in the batch. So this reduces repeated computation and improves scheduler scalability for large batch and job-based workloads. To enable this, users have to turn on the scheduler opportunistic batching feature gate, after which the scheduler automatically groups and processes compatible pods. Yeah, so up next is SIG storage. So SIG storage is responsible for storage and volume management functionality within Kubernetes. And they also have a couple of KEPs which got into this current release. One of the first one is mutable persistent volume node affinity, KEP 5381. It's in alpha in 1.35, and previously persistent volume node affinity was fixed at creation time, which made it difficult to adapt when storage moves across zones, regions, or hardware types. So this feature allows admins to modify the spec.node affinity of an existing persistent volume. So the scheduler can place pods on the correct nodes after a storage topology changes. It improves operation flexibility for dynamic infrastructure environments without requiring volumes to be created. Should we come to the questions at the end?
Yeah, I'm seeing some questions showing up into the webinar about the in-place pod updates. We will talk about that when we talk about SIG node updates, and we will answer all your questions at the end of the presentation.
Okay, sure. So yeah, as I was mentioning, it improves operation flexibility for dynamic infrastructure environments without requiring volumes to be recreated. To use this, users have to enable mutable PV node affinity feature gate and update the spec.node affinity field in the existing persistent volume object. Yeah, so the next one is CSI driver opt-in for service account tokens via secrets field, KEP 5538. So traditionally, service account tokens requested by CSI drivers were delivered through the volume context field. Since this field is often logged, it wasn't ideal for handling sensitive credentials. So in Kubernetes 1.35, this feature reaches to beta and introduces CSI token delivery via secrets. With this change, CSI drivers can receive service account tokens through the dedicated secrets field in the CSI in the CSI request, ensuring tokens are handled more securely and sanitized from logs. To enable this, you have to set service account token in secrets to true in the token request section of the CSI drivers specification. So this provides a safer and more secure mechanism for CSI drivers that rely on service account tokens. Yeah. Now let's talk about the KEPs which SIG API machinery has. Yeah, the first one is storage version mitigator. So this kept 5192, which reached beta in this current release after being introduced in 1.30. So previously, API objects for a given resource could remain stored in a deprecated storage versions, making it difficult to safely remove old APIs or perform certain cluster-wide maintenance work. So storage version mitigator addresses this by ensuring all stored objects by migrating the latest storage version. This capability is critical for safely deprecating and removing API versions, and it's also required for operations like cluster-wide secrets re-encryption. This feature improves cluster security, easier upgrades, and greater long-term stability of the Kubernetes control. Next up is comparable resource version, KEP 5504, which graduated to stable in this release. So previously, while clients could observe the resource version field, there wasn't a formal guarantee that it could be reliably compared across objects of the same resource type. So comparable resource version formalizes this guarantee. It ensures that clients can safely use resource version to determine the relative ordering and freshness of the objects, which is especially important for client-side caching and reconciliation loops. So this helps in more robust controllers, more efficient client behavior, and deterministic reconciliation logic across both custom controllers and core Kubernetes components. Next up is SIG network. So this SIG is responsible for all the networking stuff in Kubernetes project. They have a KEP which graduated to stable in this current release. It's prefers same node traffic distribution. So this feature introduces a locality aware routine option using the spec.traffic distribution field, allowing services to prefer endpoints running on the same node as the client pod. So by prioritizing same node traffic, clusters can reduce network latency, improve cache hit rates, and lower cloud provider egress costs. So along with prefer same zone, it provides a modern and stable replacement for the older deprecated prefer close mechanism. The result is more predictable, efficient, and cost-aware service traffic routing in Kubernetes. Next is SIG CLI. So this SIG is responsible for all the command line components of Kubernetes, as you all know. They also have a couple of KEPs that got into this release. One of them are separating a separate kubectl user preferences from cluster configs. that initially got introduced in 1.33 as alpha, and in this release 1.35 it graduated to beta. So traditionally, personal preferences like aliases and default flags were mixed together with cluster credentials inside the kubeconfig file, making them harder to manage across multiple clusters and environments. But this feature introduces a new kube RC config file, which provides a dedicated version location for storing client-side preferences independently of cluster connection details. From a user's perspective, users can create a file using .cube/cuberc or point to one using --cuberc flag and define your aliases and defaults there. It helps in creating kube configs, better separation of concerns, and more manageable kubectl experience across environments. This KEP also has a feature blog if you want to explore more about it. So the next one is KML. So previously, standard YAML output in Kubernetes was sensitive to white space and could lead to type ambiguity. For example, cases where values like no were interpreted as false. But KML introduces a safer opinionated YAML format. It uses explicit flow style syntax and double quoted strings to ensure configurations are unambiguous and predictable, making them easier to process with text-based tooling. So you can use the new output format using kubectl get -o km, or enable it globally using kubectl _kml equals to true. This feature helps in more reliable YAML output and fewer surprises when working with Kubernetes configuration. Yeah. So
Thank you
next
so
up is
much.
SIG apps. Yeah, over to you, Pras.
Thank you so much, Ryan. Now it's time to talk about the highlights for SIG apps. In a nutshell, SIG apps is a special interest group who covers deploying, how we deploy and operating application in the Kubernetes ecosystem. Basically, their focus is on developer and DevOps experience of running workloads in Kubernetes. For SIG apps, today we only have one update, which is the support to the managed by field into the job resources. This cap, the 4368 cap, is starting as an alpha in the version 1.30, and now is stable in the 1.35. Basically, the job API now includes a managed by field that allow an external controller to handle the job status synchronization. This feature is primarily driven by a multi-queue, which is a multi-cluster dispatching system where basically a job created into a management cluster is mirrored and executed into a worker cluster with the status updated, propagated back to the management cluster. To enable this kind of workflow, the built-in job controller must not act as a particular job, so that the external controller actually can manage the status updates instead. The goal here is to allow this kind of delegation of job synchronization to another controller. While the goal is that it doesn't not aim to pass custom parameters to this external controller or allow the external controller to actually modify the cron job concurrency policy that we already have in Kubernetes. Now it's time to talk about SIGNode. SIGNode is a special interest group responsible for the components that support the controlled interaction between pods and the host resources. They manage for example, the life cycle of pods that are scheduled to a node, and focus on enabling a broader set of workload type, including workload with hardware-specific or performance-sensitive requirement. About SIG-Node, for SIG-Node, we have 3 highlights. The first one is the one asked into the chat before, sorry, is the in-place pod update for pod resources. So Kubernetes has graduated in-place updates for pod resources to stable after a long journey of development and improvement. They started as an alpha feature in 1.27, and now it's finally stable after basically 8 cycles. This feature allows users to adjust CPU and memory resources without starting pods or containers, making actually CPU and memory mutable attributes for a pod resource. Previously, such modification required recreating the pods, which is a disruptive change for workloads like stateful workloads or batch application. Earlier, Kubernetes release allowed you to change only infrastructure resource setting like requested limits for the workload for existing pods. But now the new in-place update functionality allows for smoother and not disrupting vertical scaling, improving the efficiency and improving how we manage the vertical scaling for the resources deployed on Kubernetes. The next one is the supplemental group policy pod field that was introduced as an alpha feature for Kubernetes 1.31. And then had graduated to beta in 1.33, and now in 1.35 is finally stable, which means that it's generally available. This feature allows you to implement more precise control over supplemental groups in Linux containers that can strengthen the security posture, particularly in accessing volumes. Moreover, it also enhanced the transparency of user ID or group ID details into the containers, offering improved security oversight. This field basically lets you control how Kubernetes calculates the supplementary group for container processes within a pod, and the available policies right now are 2. The first one, which is the default one, is merge. It is the default option, so if not specified, we are going to use the merge option, and basically allow to merge the group membership for the container's primary user. And the second one is the strict policy that allow you to attach only the group ID specified in, for example, FS group or supplemental groups, or run as a group as a supplementary groups for the container processes. And this way, groups membership defining the ATC groups path for the container's primary users are actually ignored. Next, we have the support for a drop-in kubelet configuration directory, which is now stable in Kubernetes 1.35. This newly stable feature simplify the management of kubelet configuration across layered, large, or heterogeneous cluster. With this feature, the kubelet command line document config.dir is production ready and fully supported, allowing us to specify a directory containing the kubelet configuration drop-in files. All files in that directory will be automatically merged within your kubelet configuration, allowing cluster administrator to maintain a cohesive base configuration for kubelets while, let's say, enabling targeted customization for different node groups or use cases, and without actually using complex external tooling or manual configuration. Now is finally time to talk about deprecation and removal for this release. As I previously mentioned, we have mainly 3 different deprecation with one outsider, which is not strictly related to this release cycle itself, but is worth mentioning. The first deprecation, the first removal we want to talk about is the removal of cgroup v1 support. Kubernetes introduced support for cgroup v2 back in 1.25, if I remember well, offering actually a much cleaner, unified hierarchy and actually a better resource isolation compared to the cgroup v1. Because now cgroup v2 is the modern standard in the Kubernetes project, the project is ready to retire the legacy cgroup v1 support in Kubernetes v1.35. This is actually an important notice for cluster administration, that should take care that if you are still running nodes on older Linux distribution that doesn't support cgroup v2, your kubelet will fail to start, and so you will need to migrate those nodes to systems where cgroup v2 is actually enabled. The next one is the deprecation of IPVS mode in kubeproxy. Kubernetes adopted the IPVS mode in kubeproxy to provide faster load balancing than the standard IP table, while it offered a performance boost, keeping it in sync with evolving networking requirements created too much technical depth and complexity. And because of this maintenance complexity, Kubernetes v1.35 deprecates the IPVS mode. By the way, IPVS mode remains available in the release. Kubeproxy now will emit a warning on startup when configured to use IPVS mode. The goal is to streamline the code base and focus on modern standard. Which is the alternative for Linux nodes, you should begin transitioning to NF tables, which is now the recommended replacement. Last deprecation is the final call for Containerd version 1 series. This is not new, but in v1.35 is the last supported version for Containerd v1. So basically, while Kubernetes v1.35 still support the Containerd 1.7 and other LTS releases, this is actually, as I said, the final version that supports this series of version for Containerd. The community has designed the v1.35 as the latest release to support this kind of series of Containerd version. So before upgrading to the next Kubernetes version, you must switch to Containerd 2.0 or later, of course. And to help you identify which nodes need your attention, you can monitor a specific metric, which is a specific metric on your cluster, which is the kubelet CRI losing support metric. Now it's time for the outsider I mentioned at the beginning of this section. While not properly related to the Kubernetes release, to the v1.35 cycle, it's worth mentioning that the Ingress Nginx is retired. The Kubernetes project announced it during KubeCon North America, I think so. in November last year, 2025. The project, Ingress and Nginx, will receive only best effort maintenance until March 2026. So for the next less than 2 months, a month. And after this date, it will be archived with no further updates due to the unsustainability of maintaining this project itself. The recommended path here is to move to the modern and secure extensible standard, which is the Gateway API. Next one, we actually finished talking about the single caps, the single highlights for Many6, and it's time now to talk about some updates from us, from the release team. So during this cycle, we have improved our production readiness process, introducing hard deadline to finish the production readiness questionnaire for the caps, which is the production readiness review freeze, or PRR freeze, that now happen a week before the announcement freeze, which is another deadline already in place into the release process. Then talking about more my side, so about the comp side, if you want to learn more about most of the features that we discussed today, you can visit the official Kubernetes blog, where we published 12 feature blog posts going into more details about the feature we implemented, the implementation of the feature, and how this feature can be useful for your use cases. Talking about the contributors community, the contributor stats for this cycle said us that during the cycle, we had more than 400 individuals contributing to the project. To be precise, 419 from 85 different companies. Now, it's time for a quick recap and some other links that can be useful to you to understand better the changes of this release and understand better how the release engine actually works. To have a complete overview of the changes made within this cycle, I highly recommend to check out the release note and the release announcement blog, where you can find all the changes and the recap of all the caps, even the one we didn't have time to talk about today. Instead, if you are interested to know more about a specific cap, you can check the cap document linked into this slide, or check out the official Kubernetes blog and documentation for the related features. Of course, this slide deck will be available in our SIG release repository on GitHub soon. If you are interested to get involved into the project, we always welcome new contributor. You can check our community repository on the Kubernetes GitHub organization to have an overview of the available SIGs and how to start contributing in their activities. Or if you are interested about the SIG release itself, how we work, you can check our SIG release repository in the Kubernetes GitHub organization and learn more about the release process. Of course, both SIG release and the other SIG have their own specific channels on the Kubernetes Slack workspace, so feel free to join us there and ask any question you may have. Last but not least, if you want to contribute to the future release cycles, subscribing to the official Kubernetes mailing list, which is the best place to get all the information you need about the SIG release shadowing application, for example. All the links I mentioned now are into the slides that you can find later into our Kubernetes repository. It's everything for today. Thank you so much to everyone who joined the webinar. Thank you so much for everyone who contributed to the release. And thank you so much, Audra and the other or from the CNCF organization that have us here today. Thank you.
Thank you. It's no small feat to be managing a release. So kudos to you both, and thank you for sharing the updates. We really only have one question, so you saw it a little bit earlier, but let me showcase it again here on the screen. They acknowledge version 1.35 and in place update of pod resource feature reached general availability. What's the direct technical impact of this change on container lifecycle management?
Okay, so technically speaking, I'm still studying the improvement itself. But as someone I saw said in the chat, the impact of the change is that now CPU and memory for the pod resource, not for the controllers like deployments, is mutable attributes of the resource itself. So you can change, edit the CPU and memory for a single pod without the need to restart the pod itself. It can be useful, for example, using the VPA, vertical pod scaler, which already supports this feature. If you want to learn more about that, the SIG node community wrote an interesting article on the Kubernetes official blog, which explain all the trade-off of the feature right now, how it works, how it is implemented, and how you can use it.
Awesome. And additionally, I mean, you mentioned to ask questions elsewhere, but would this allow dynamic changes to the CPU and memory requests and limits fields in the pod specification without triggering container restarts? We had someone in the chat address this as well, so their question may have already been answered. But if you have any additional context.
Yeah, the quick answer is yes, basically. It is not working on the... Well,
yeah,
go ahead,
you have to
Ryan.
update the pod spec with all the changes, and it will just update the resources without even restarting the container.
Yes.
Awesome. Well, that was it. Everybody said thank you. Very insightful. Lots of clapping emojis, excellent changes. So you've got good feedback so far from this audience.
Thank you.
Yeah, if there's anything additional you'd like to say, now's the time in the last minute. Otherwise, we at CNCF thank you, our release team, for your time and dedication to the community. And thank you, audience, for attending. We'll see you at the next online program. But Ryan, Graciano, please say your last words.
Thank you so much, guys. See you next time.
Yeah, thanks, folks. See you next time.